Settle in and let's explore the sleepy secrets of the night sky. Look up at the night sky, far away from the bright city lights, and you might see it, a faint, glowing river of stars, a band of light that has captivated humanity for thousands of years. The ancient Greeks called it the Milky Circle, and in China, it is known as the Silver River. Every culture has its own name for this cosmic home, a place of mystery and wonder. But what if the true story of this cosmic river is far more incredible than any myth? What if every single star you see is part of a grand design, a place of unimaginable size and unbelievable speed?
This is our home, the Milky Way galaxy. It is a place of 100 billion stars and 100 billion questions. In this documentary, we will take a journey to uncover its secrets, to learn about its structure, its history, and its future. We will explore some facts that will redefine your understanding of our place in the universe. Before we begin our journey, let me ask you a question. Wherever you are in the world, what time is it in your country right now? Feel free to share your country name and the time in the comments below. Now, find a comfortable position. Close your eyes and imagine you are standing on a quiet hill, far away from all the city lights. Above you, the sky is a blanket of soft darkness, and through it, a faint glowing river of stars stretches from one end to the horizon. It's a band of light that has captivated humanity for thousands of years. The Milky Way is a band of light in the night sky. For thousands of years, civilizations across the world looked at this celestial river and tried to make sense of it. The ancient Greeks saw it as a stream of milk from the goddess Hera, giving it the name Galaxius Caicals, or Milky Circle. To the Incas, it was the Mayu, or Celestial River, a sacred pathway. In the Kalahari Desert of Africa, it was called the backbone of night, a cosmic spine holding up the universe. Each of these bedtime stories and tales was a way of giving meaning to something so vast and mysterious. But what we are really seeing is a simple truth of our place in the universe. Our galaxy is shaped like a giant flat disk, a barred spiral galaxy. Imagine holding a very thin, circular book in front of your face. You can't see all the pages at once. What you see is the side, a long, thin shape made up of the edge of every single page. The same is true for us. We live on one of the spiral arms of our galaxy, deep within its flat disk. When we look out, we are looking sideways through the immense disk of stars, dust, and gas. What appears to be a faint, scattered band of light is, in reality, the combined glow of billions upon billions of stars, all piled up in our line of sight. We are not looking at the whole galaxy. This is the beautiful, simple truth of our cosmic river. It's not a river of milk, and it's not a myth. It is the overwhelming collective light of our home, stretching across the sky, a silent reminder of our place inside this truly vast and magnificent structure. We've just seen our galaxy as a beautiful band of light in the sky. But where are we within this vast cosmic home? Fact number 2. Our solar system's location, our galactic address. Imagine our galaxy as a bustling, vibrant city. The very center, a bright, crowded metropolis, is full of activity, bright lights, and immense chaos. Now, think about where we live. We are not in the downtown core. Our home is located in the quiet suburbs of the Milky Way. Our address is about 26,000 light-years away from the galactic center. Fact number 2. Our solar system's location, our galactic address. Imagine our galaxy as a bustling, vibrant city. The very center, a bright, crowded metropolis, is full of activity, bright lights, and immense chaos. Now, think about where we live. We are not in the downtown core. Our home is located in the quiet suburbs of the Milky Way. Our address is about 26,000 light-years away from the galactic center. We reside on one of the galaxy's smaller spiral arms, often called the Orion Cygnus arm or the Orion Spur. We are nestled between the larger and more populated Sagittarius and Perseus arms. This location is an incredibly fortunate one. It is a quiet neighborhood, a calm, safe place. We are far enough from the incredibly dense, active center of the galaxy, a place teeming with dangerous radiation, powerful black holes, and stars packed so close together that a supernova could be a yearly event. But we are also close enough to benefit from the galaxy's stellar history. The elements that make up our planet, our bodies, and everything we see around us were forged in the hearts of older, bigger stars that lived and died closer to the galactic center. We are in the perfect cosmic sweet spot, a Goldilocks zone for life. So, when you look at that band of light in the sky, remember that you are not just looking at stars. You are looking at the neighborhood you call home, and it is one of the most ideal spots in this incredible cosmic city. We know where we live in the galaxy, but what does our home actually look like from the outside? What is its shape? Fact number 3. The Milky Way is a barred spiral galaxy. For many years, scientists believed our galaxy was just a regular spiral galaxy, a beautiful pinwheel of stars with arms curling out from the center. But modern technology and observation have revealed something even more spectacular. Our galaxy has a prominent, dense bar of stars right at its core. Imagine a giant, luminous spinning top. At its heart, instead of a simple point, there is a brilliant, glowing bar of light. This bar, which is about 27,000 light-years long, is made up of billions of stars packed tightly together. It acts like the central engine of the galaxy, a powerful cosmic spine from which the majestic spiral arms flow. The arms themselves are the nurseries of the galaxy, the places where new stars are born. Our own spiral arm, the Orion Cygnus arm, is just one of these beautiful cosmic pinwheels, and it is here that we find ourselves. Surrounding the central bar and the flat spinning disk is another, even larger component, the galactic halo. This immense spherical cloud is filled with ancient, scattered stars, and most importantly, the mysterious dark matter we will discuss later. It envelops the entire visible galaxy like a ghostly protective shield. So, the Milky Way is not just a single shape. It is a spectacular, multi-layered structure, a glowing central bar, thin curving arms of stars and gas, and a vast, invisible halo. And we are a small part of this incredible, spinning cosmic masterpiece. We've now established that our galaxy has a beautiful spiraling shape, but to truly understand its form, we have to talk about its scale. Fact number 4. While the Milky Way is immensely wide, it is also incredibly thin. The numbers alone are hard to grasp. Our galaxy's disk is about 100,000 light-years across, but it's only around 1,000 light-years thick. This means its diameter is roughly 100 times greater than its thickness. To put that into perspective, imagine an everyday object. If the Milky Way were the size of a standard vinyl record, about 12 inches in diameter, its thickness would be no more than the thinnest piece of paper. If it were a giant dinner plate, its height would be that of a single grain of salt sitting on its surface. So, why is our galaxy so thin? It's because of its constant, elegant spin. All the stars, gas, and dust in the Milky Way are orbiting the galactic center, creating a massive organized vortex. Just like a pizza maker spinning a ball of dough, the centrifugal force of this rotation flattens the material out into a thin, beautiful disk. This spinning ballet has shaped our home for billions of years, forcing nearly all the stars and gas into a single, two-dimensional plane. This fact is a powerful reminder of how empty space truly is. Even in a galaxy with hundreds of billions of stars, they are spread out so thinly that if we were to turn the galaxy on its side, it would disappear almost completely from view. We've just explored the beautiful flat shape of our galaxy, held together by its magnificent spin. But there's a problem with this picture. According to the laws of physics, a spinning disk of stars and gas should be flying apart. The stars on the outer edge are moving too fast to be held in place by the gravity of the visible stars alone. Something else is holding the entire thing together. This is one of the greatest mysteries in all of science. Our galaxy is surrounded by a massive, spherical halo of a substance we call dark matter. It's an invisible, ghostly presence that makes about 90% of the Milky Way's total mass. Everything we can see, every star, every planet, every cloud of gas, is just the tip of the iceberg, a small fraction of what's truly there. We call it dark because it doesn't interact with light at all. We can't see it, we can't touch it, and it passes right through us without a trace. So, how do we know it exists? The evidence is in the stars themselves. By measuring how fast stars are moving on the very outer edges of our galaxy, astronomers have found that they are moving far too quickly to be held in place by the gravity of the visible stars alone. The only explanation is that there is a massive, unseen gravitational force, an invisible scaffold holding the entire cosmic structure in place, keeping the stars from flying apart into the void of space. This immense, unseen halo of dark matter is the true cosmic glue of our galaxy. It's a silent, powerful guardian, a reminder that the universe is far more complex and mysterious than it appears. We've seen that our galaxy is a beautifully flat disk, but that's not the full picture. If you could see it from the outside, you would notice a subtle, yet unmistakable bend. Fact number 6. The Milky Way's disk is warped, a result of gravitational forces from its satellite galaxies. Our galaxy isn't alone. It is constantly engaged in a slow, cosmic dance with its smaller neighbors. The most famous of these are the Large and Small Magellanic Clouds, two dwarf galaxies orbiting the Milky Way. These galactic companions are our own personal gravitational bullies. Even though they are small in cosmic terms, their immense gravity is powerful enough to tug on the outer edges of our galactic disk. Imagine a giant flexible dinner plate. As two smaller marbles roll around its surface, their weight and pull cause the plate to bend and warp in a subtle wave-like motion. That is what is happening to our galaxy. This warping isn't just a gentle pull. It is a slow, relentless force that has been shaping our home for billions of years. As the Magellanic Clouds orbit our galaxy, they pull on the stars and gas in the outer disk, causing a sort of wobble that can be seen from a great distance. This subtle bend is a visible sign of the dynamic, ever-changing nature of our universe. This cosmic engine is called Sagittarius A star, or SGR for short. For decades, its existence was a mystery, only confirmed by observing its powerful gravitational effects. We couldn't see it, but we could see what it was doing to everything around it. It's a monster, with a mass of about 4 million times that of our sun. To grasp that, imagine our sun, then multiply its mass by 4 million. All of that is packed into a space smaller than the orbit of Mercury. For years, the black hole remained unseen, a ghost in the cosmic machine. But on May 12, 2022, after years of work by an international team of scientists, we saw it for the first time. The Event Horizon Telescope, a global network of radio observatories, created a virtual telescope the size of Earth. It captured the first direct image of the black hole's shadow, a dark central region surrounded by a bright ring of glowing gas. Imagine trying to take a photo of a single blueberry on the surface of the moon. That's how difficult it was to get a picture of Sagittarius A star from Earth. To solve this impossible challenge, scientists built a virtual telescope as big as our entire planet. This instrument, called the Event Horizon Telescope, or EHT, is not a single dish, but an array of 8 radio observatories spread across the globe, from Antarctica to Spain. For 5 straight nights, these telescopes pointed at the same precise spot in the sky, collecting a colossal amount of data, about 350 terabytes a day, per telescope. Because the data was too massive to be sent over the internet, it was physically flown on hard drives to specialized supercomputers in Germany and the US. There, a team of over 300 scientists used new, complex algorithms to painstakingly combine all the information. They worked for 5 years, turning a mountain of data into a single, breathtaking image. What they revealed was not a black orb, but a shadow, a dark central region surrounded by a bright ring of glowing superheated gas. This ring is the very edge of the black hole's gravity well, where gas and plasma, heated to billions of degrees, are orbiting the point of no return, at nearly the speed of light. The light from that gas is what allowed us to finally see the shadow of the unseen. For a long time, the existence of a supermassive black hole at the center of the Milky Way was a hypothesis, not a proven fact. Scientists believed it was there, but they needed undeniable evidence. They found that evidence by simply watching the stars. For a long time, the existence of a supermassive black hole at the center of the Milky Way was a hypothesis, not a proven fact. Scientists believed it was there, but they needed undeniable evidence. They found that evidence by simply watching the stars. Fact number 9. The evidence for the black hole's mass comes from the stars orbiting it. Imagine you're watching a carousel. You can't see the central pole holding it all together, but you know it's there because of the way all the carousel horses are moving around a single invisible point. Astronomers did the same thing with the stars at the very heart of our galaxy. They focused their telescopes on the crowded central region of the Milky Way, watching the motion of individual stars. One star in particular, named S2, became the key to unlocking the mystery. For nearly 3 decades, 2 teams of astronomers at different observatories painstakingly watched S2 as it completed a full orbit around the galactic center. They focused their telescopes on the crowded central region of the Milky Way, watching the motion of individual stars. One star in particular, named S2, became the key to unlocking the mystery. For nearly 3 decades, 2 teams of astronomers at different observatories painstakingly watched S2 as it completed a full orbit around the galactic center. They discovered that S2 completes a full revolution every 16 years. That's an astonishingly short period for a star in a galaxy. They calculated its speed at its closest approach to the black hole, a blistering 17 million miles per hour, 27 million kilometers per hour. This incredible speed proved that S2 was being pulled by an enormous gravitational force. The only object that could possess that much mass, packed into such a tiny space, was a supermassive black hole. But the scientists found even more. The star's orbit wasn't a perfect oval, as predicted by Newtonian physics. Instead, its path shifted with each revolution, creating a rosette-like shape. This subtle dance known as Schwarzschild precession, was exactly what Albert Einstein's theory of general relativity predicted would happen in the presence of an incredibly strong gravitational field. The patient observation of a single star's orbit not only proved the existence of the black hole beyond any reasonable doubt, we've now established that our solar system is a tiny part of the great galactic metropolis. But our home isn't standing still. It is on a journey that defies all imagination. Fact number 10. The speed and duration of our solar system's orbit. Our entire solar system, the sun, all its planets, and everything else in between, is rushing through space at an incredible speed. We are hurtling around the center of the Milky Way at an average of 515,000 miles per hour, 828,000 kilometers per hour. To put that into perspective, at that speed, you could travel from New York to Los Angeles in just 30 seconds. And yet, this isn't even the fastest part of our galactic journey. Despite this mind-boggling speed, the sheer size of the Milky Way means it takes an incredibly long time to complete a single lap. The solar system takes approximately 230 million years to orbit the galactic center just once. This period is sometimes referred to as a galactic year. Think about what that means for our planet's history. The last time our solar system was in this exact spot on its galactic journey, dinosaurs were just beginning to walk the Earth. The continents were in completely different places, and flowering plants had not yet evolved. Now, the journey is coming to an end. We have traveled to the quietest corners of our mind, and through the quietest parts of our cosmic home. Your body is heavy, and your mind is calm. All is quiet. All is well. May this sleepy story help you find the peace you've been looking for. This quiet journey is designed to be a form of sleepy science and deep calm, with its soothing narrative serving as a guided meditation for your mind. Let the gentle atmosphere and relaxing sounds of the cosmos carry you away. This is your personal journey for deep sleep, a peaceful and calming tool to help you get sleepy and fall asleep fast. Thank you for joining us on this journey. This sleepy story was brought to you by Sleepy Zone.